Nuclear energy. What is nuclear energy? Nuclear energy is the energy released by either one of the following processes. The first process is called nuclear fission, 核分裂. The second process is called nuclear fusion, 核匯聚. Now let's see the first nuclear energy release process called nuclear fission, 核分裂. What is nuclear fission? Nuclear fission is a reaction for which a heavy nucleus is split into two lighter nuclei, and at the same time neutrons are produced. Then, what is the necessary condition for nuclear fission to occur? For nuclear fission to occur, the necessary condition is that the heavy nucleus is hit or bombarded by a slow neutron. As shown in the diagram, when a slow neutron hits a large nucleus, nuclear fission will occur such that two small nucleus are produced, and at the same time neutrons are produced. In nuclear fission, energy is also released. See, why slow neutron instead of fast neutron is used to hit the heavy nucleus in a fission process? Because slow neutron is more easily to be captured by the heavy nucleus and to split it into smaller nuclei. Let's see an example of nuclear fission in many nuclear power plants, 核電廠. The example is the slow neutron hit a uranium-235 nucleus and split it into two smaller nuclei. The first one is barium-144 and the other is captron-90. At the same time, two neutrons are produced and energy is released. What makes the nuclear fission process to be continued? The reason is that the neutrons emitted by fission process will hit other uranium-235 nuclei and split them into lighter nuclei. Therefore, this fission process can be continued. And the above process is called chain reaction, 連鎖反應. F. What is the necessary condition for a chain reaction to occur? For a chain reaction to occur, at least one neutron is emitted in a nuclear fission process. Let's see the diagram for a chain reaction. The first neutron captured by the uranium-235 nucleus and split it into smaller nuclei, and at the same time neutrons are produced. The neutron produced will hit other uranium-235 nuclei and split it into smaller nuclei, and at the same time, neutrons are produced. The neutrons produced during nuclear fission process enable the fission process to be continued, which is called a chain reaction. Another way to produce nuclear energy is called nuclear fusion. 核聚合. What is nuclear fusion? Nuclear fusion is a reaction in which lighter nuclei combine to form a heavier nucleus, and at the same time energy is produced. B. Why nuclear fusion is more difficult to occur than nuclear fission? The electrostatic force between them is repulsive and is very strong. Therefore, it is difficult for them to combine together to undergo fusion. See, what is the necessary conditions for nuclear fusions to occur? In order the nuclei can fuse together, the temperature must be very high, as high as 10 to the power 7 degrees Celsius. At this temperature, the speed of the light nuclei are sufficiently large enough to overcome the strong repulsive electrostatic force. As a result, the light nuclei will combine together, or we say can fuse together. D. Let's see a diagram for nuclear fusion. In a nuclear fusion, two light nucleus fuse together to form a heavy nucleus. At the same time, energy is released. Very often, in nuclear fusion process, other light nucleus, such as neutrons, will be produced. Part E. Let's see an example of nuclear fusion, which is the solar energy produced by the sun. In the sun, the temperature in the core is larger than 10 to the power 7 degrees Celsius. Therefore, the fuel inside, which is hydrogen-3 and hydrogen-2 nuclei, have high enough speed to combine together to form helium-4 and neutron. At the same time, energy is released. The equation for the nuclear fusion is hydrogen-3 fuse together with hydrogen 2 to form a heavier nucleus called helium-4. At the same time, a neutron and energy is released. The diagram is that hydrogen 3, hydrogen 2 fuse together to form a heavier nucleus helium-4, and at the same time neutron and energy released. Look at solar energy is a typical example of nuclear fusion.